Here's the power plant for my helicopter. Let's see here. I'm going to get rid of a few things. That. And that's already there. Okay. As you can see, it's chain drive. This is just the power plant. Requires a lot of tuning. These are collectors up here, these that I'm touching with the mouse cursor. It's a hydraulic power plant. And I will go to the helicopter in just a moment. This is the rear side. The operator is up this end, and the tail rotor's back over here. Alright, I'll turn this off now. Set it back where it's supposed to go. Alright, that's that. Okay, here's a production in CAD. I'll show you close. Here's the power plant. As you can see, it's assembled into the helicopter. Back up. And it's real sticky because I have the wrong graphics card in here. Doesn't work well with CAD software. Let's see, where am I? Here we go. Okay. There. There we go. Oops, click it back on again. Alright. Here's the helicopter. Anyway, I want to rotate it around. Try to make it fly here. There we go. Right. Here's the crank mechanism, the operator's compartment. You can see there's handlebars. And the control mechanism right here with all these vertical rods. Zoom in a little bit. Then there's the twist mechanism in the middle for the handlebars. There's the three-dimensional function of how they work, all the pitch, roll, and yaw. There's the trim knob over here. The trim knob operates down here. There's the worm gear. Here's the gear that it drives, and it will, as you can see here, rotates freely from the control mechanism. When you twist the trim knob, it will operate the tail rotor blades, and you can adjust your straight ahead attitude while you're flying. And here's the flywheel. It's calculated to produce approximately the same amount of force as you go over the top on the crank. Let's see here. There's my swash plate. It's much too big. It's just a design. And it operates off the controls, off the handlebars with pitch and roll. Here is the reservoir. These are the hydraulic lines, these tubes. Here's the power plant, secondary power plant. And the primary power plant runs this impeller, which operates this power plant. It sends the hydraulic fluid through this impeller at the top, which turns the rotor, the lift rotor, and it's all calculated to apply all the necessary performance variable forces. Here's the secondary power plant for the tail rotor. Has its reservoir over here. The hydraulic tubing goes back to this impeller, which turns the tail rotor. And here's the tail rotor pitch control mechanism. It operates here and here, pulls this turns this on this Acme screw down here, which pushes this disc back and forth, which will operate the tail rotor blades pitch, and they're designed to lock out at maximum in either direction. I think maybe not, maybe just, I don't know, maybe the other direction. It's been a while since I did this, but is when this slides all the way over, and that limits the maximum performance of the blade vanes in the opposite direction, while that right there limits the performance of the pitch blades pitch. And when this is pulled in, when it goes the other way, when it's pushed out, this goes out to here and stops, and that would be the limit. In the other direction, this is the alternator, and the tail rotor spins the fastest, so that's where I put the alternator. I intend to have a 12-volt electrical system on it with running lights and strobes and oscillating grid on the tail and a landing light. So that's one. I'll show you another one. Bicycles, or the top one's a bicycle, the bottom one is a tricycle. You can see the top one is finished for the most part, being drawn and assembled. It's kind of hard to look at it with the tricycle underneath. There's the rear view. It would probably be a little difficult to keep upright if it was heavy. The tricycle, I didn't finish drawing it. It just took too much time. But I can improve it a little bit. It's been a while since I put this one together. It's pretty much the same as this one. There's just some parts that I haven't put in yet, and I put 3 wheels on it. It'd be easier to keep stable. Anyway, it's designed is for 200 miles an hour top speed, and you can see it's pretty wide. Level it up here, but the outboard wheels would manage to make it more stable. Well, it's just pretty much a similar power plant as the helicopter and the dragster. So the dragster only goes 30 miles an hour faster than these. Here's my all-wheel drive vehicle. It's maybe made shorter, and there's some design parameters I need to alter. It's got all-wheel drive and forward and reverse. The throttle is down here, which I don't have hooked up, but this throttle is right there on the handlebars, and there'll be brakes, of course, and it's designed to take 2 people. It's got 2 sets of pedals. It isn't finished. I haven't put in all the tubing. The front wheel drive comes out of here on this blue tube. The diameters are all calculated. The steering is up inside here, you can see, and here's the reverse forward control valve. These blue tubes here, I think it's blue tubes there, and I can see it, it's on top here. The yellow tubes here change the fluid flow from forward to reverse. Here's the forward and reverse lever, and it operates all these control linkages under here, and it goes both to the rear and to the front. and goes up the red, goes up to here and operates forward and reverse. It's got 4-wheel disc brakes and the chain drive. Let's see here. Okay, the chain drive, I recently determined how to ascertain where to put chain rings in relationship to one another, and I haven't done that arithmetic on this vehicle, but I have on the next one I'm going to show you. Here, what you just saw was, what was I saying? Let's see. For groceries in the wintertime, go and get your groceries. This is the preliminary design for Bonneville at Salt Lake, Utah. This vehicle, as you can see, doesn't have a frame yet. It still hadn't loaded, so I'm not able to move it at all. There it is. Doesn't have a frame. I haven't finished it. Come on, this one's really sticky. I'm not able to get it to move. The frame is started, but it's just in the rear end. The design parameters of this type of craft is at 800 miles an hour. I haven't put in any tuning yet, and it's still not responding. That is designed to go 800 miles an hour. I may be able to, I may not. You know, that's just how it's designed. Stupid graphics card. I know. Okay, let's see. There's the top here, and all of the chain drive. I don't have any chains on it yet, but this one is calculated with the necessary spacing for sprockets, like from here to here, and the jockey wheels, and then this one. They're all specifically aligned with mathematics. And here's the front end. I started the frame. It needs some work. The shock absorbers are a little excessive on the front end. It has rack and pinion steering, and the adjustment on these is for a straight line vehicle travel, so it doesn't go around any corners. And the differential back here in the back, it has impeller, what do they call that in the automatic transmission? What's it called? Torque converter in there on both sides of the impeller. And it has sponges for suspension. They're not connected to anything yet. Anyway, that's that one. And I'll show you one more. I'll go to the dragster next.